Hi everyone, in this lesson you're going to learn how to solve exponential equations. So on the previous 3 lessons you learned how to solve log equations. So now we're switching to exponential equations, and the goal to when you solve exponential equations is you want to get x down from the exponent so we can isolate it and then solve. Okay, so the steps are: step number 1, you want to isolate the base, that is the number that has an exponent or a power, and then once that's isolated you can convert to log. And step 3 is you solve the equation, but now you're going to use a calculator for this. Okay, so let's go over the first example. So notice this is the base and it's isolated. So once this is isolated, we can go to step number 2. So you take the base of the exponential, and this becomes the base of the log. Okay, you'll be taking the log base 5 of this number, and that's going to be equal to the value of x. So that means x equals log base 5 of the number 18. So then for this, you go to the calculator, you're going to press the alpha key. Okay, press alpha, then the window, and then the number 5. So I'm going to go over this with you in this video. So there are 3 keys you're going to press. So I'm going to go to my calculator and press alpha, so this is the alpha key, and then the window key, this is the window key, and then 5. So 5 is log base. So what this is going to help you do is it's going to help you enter the base of the log. So in this case the base is 5, so I'm going to enter 5, and then inside of the parentheses I'm going to enter 18, then press enter, and it gives me the answer. So for this one I'm going to round to 2 decimal places. So x is approximately 1 point, and this is 795. So I'm going to make this 1.80. Okay, so this is the approximate solution to this equation. So on the assignment in class, make sure you round to 2 decimals, okay, or 2 decimal places. So that is all for example number 1. Example number 2, again, the base is isolated, so we can right away go to step 2. So convert to log. The base of the log is going to be 8. So log base 8 of 360 equals 3 times x. So 3x equals log base 8 of 360. And for this one, I'm going to divide by 3, and I can enter this all at once in the calculator. Okay, so then I'm going to go to the calculator. I'm going to use the alpha key. So alpha, and then this key. I have, I'm going to press now alpha window, okay, 5. The base of this log is 8. So this is 8, and then the number is 360, and we're dividing this by 3. And then press enter, and it gives me 0.9435. So this means that x is approximately, or equal to for now, 0.94. And that's the solution to this equation. Okay, so moving on to example number 3. Again, this base is isolated, so we can go to step number 2. So take the base of the exponential, that becomes the base of the log. So we have, okay, let's see, so this is the base, this will be the number we'll be taking the log of, and we set that equal to 2x minus 1. So 2x minus 1 equals log base 3 of 3.96. Then I'm going to add 1 to both sides. So then this becomes 2x equals log base 3 of 3.96. And I'm going to put this inside of a parentheses because I don't want you to think that you can add 1 to this. Okay, you cannot. This belongs to the log, that 1 doesn't. Then I'm going to divide by 2. I'm going to divide this side by 2 and also this side by 2. Then I'm going to go to the calculator and enter all of this at once. So I'm going to use the alpha key to get the fraction. So then we have alpha window 5. The base of this log is 3. The number we're taking the log of is 3.96. And then scroll out, add 1 more to it, and then divide by 2. And press enter, and it gives us 1.126. So then x for this problem, okay, x is equal to or approximately 1.13, and that is the solution to this equation. Moving on to example number 4. Before I go into example number 4, let me give you a quick reminder. So let's say we have x to the third, right? And this is being raised x to the 1/3 power. So this equals, let's say we have 9, right? So what I'm doing here is, maybe let me go back and explain this. So I want to get rid of the cube. To get rid of the cube, I'm going to take the 1/3 power. So I'm going to show you how to do this without, you'll see this on the assignment, but I'm going to teach you an easy way to do this, and that is you'll be taking the reciprocal power, but I just want you to see this. Maybe might be useful for to some of you, but if this doesn't help you, then just ignore it. Okay, so I'm going to teach you the easy way on how to do this, which we have done in class, by the way. So example number 1, this says log base x of 2.1 is equal to 4. So then we convert this to exponential. So take the base of the log, raise it to this power, and set it equal to 2.1. So that means x to the 4th power is equal to 2.1. But then this is what that means, okay? I want to get rid of the 1/4 power. So I'm going to multiply by the reciprocal of 4, the 4th power, so multiply by 1/4. So then raise 2.1 to the 1/4 power. So then this will give us the x by itself. Okay, then I'm gonna go into the calculator and do 2.1 and raise that to 1 divided by 4 as a power, and then press enter, and it gives me 1.203. So x is equal to 1.20, and that is the solution to this equation. So basically that's what I'm saying here. You have a cube, then take the reciprocal of the cube, which is a 1/3, and by the way, that's the cube root. In case you don't remember, we have done that in class. So let's go to number 4. So for this one, see how this base is not isolated. There is a -1. So we need to add 1 to both sides of the equation. So then now this becomes 5 to the x plus 1 is equal to 3. Okay. So then for this one, we have the base isolated. Let's take the log. So the log, the base of that log is 5. Okay, so I'm going to take that 5, log base 5 of this number is equal to x plus 1. So let's see. So this is log base 5 of the number 3 is equal to x plus 1. Then I'm going to subtract 1 from both sides of the equation. So then this becomes log base 5 of 3 in parentheses minus 1 is equal to x. So then I'm going to go to the calculator and press alpha window 5. The base of this log is 5. The number is 3. Then I'm going to subtract 1 from it, and that gives me negative 0.31 or 317. So then I'm going to come over here and say that x is equal to negative 0.32, rounding up to 2 because we have a 7. Okay, so that is a solution to this equation. So let's move on to the next example. Now notice we have a negative in front of the log. That's implied to be a -1. So I am going to divide by a -1 on both sides of the equation. So divide this by -1 and this also by -1. So then this changes to positive 10 to the x power is equal to positive 182. Now, as you can see, the base of this exponential is 10. So that means this, when you take the inverse, this will be the common log. So then this is the common log. You don't have to write the base. It's implied to be 10. Common log of 182 is equal to x. So for this one, I can just go to look. This is the common log on the calculator. So common log of 182, and that gives me 2.26007. So then x is equal to 2.26, and that is the solution to this equation. Okay, so now let's go to the last example. So in this case, we're going to convert to exponential. So we take the base of the log, which is x, raise it to this power and set it equal to 47. So we have x to the 6.3, and this is running out of ink, so let me go back to this, switch to this color, 6.3. So this is equal to 47. Now, 6.3, you can rewrite this as x to the 60th power over 63, I'm sorry, 63 over 10. Okay, so converting from decimal to fraction, this is over 10, and that equals 47. Now, we take the reciprocal power of this side and also of the 47. So then this becomes 10 over 63 as a power, and we do the same thing on this side of the equation, 10 over 63. Then I'm going to go to the calculator and enter this as it is here. So 47 raised to the 10 divided by 63 power, enter, and it gives me 1.84. So then 1.8425, so then the solution to this equation is x equals 1.84. Okay, and that is the solution to this equation, and that's all for this lesson. I'll see you guys in class. Bye-bye.